Hi everyone, my name is Audrey McGill Sawyer, a DBA student at California Intercontinental University. I am currently on the GRC 605 course by Dr. Nigel Baxter. Today I'll be presenting my views on visualizing hypothesis testing. Before we get into visualizing our hypothesis testing, let me take a few moments to give you a rundown of our session today. I will start by defining or explaining a few key terms. Then we'll look at the four hypotheses in detail, and we'll conclude with a number of key concepts I'd like you to take away from my presentation. According to Sekaran and Bougie, a hypothesis is a testable statement which predicts what you expect to find in your empirical data. The key word here is testable. For your statement to be called a hypothesis, you must be able to test it and expect clear, undeniable results one way or another. A statement that cannot be subjected to scientific testing can therefore not be called a hypothesis. For example, a statement like God answers prayer can never be a hypothetical statement because there's no scientific method of testing if there is a God. Neither is there a testable method of proving that it answers prayers. This requires faith. According to Investopedia stock analysis, a null hypothesis is the result of no significant correlation between two variables. For example, if we wanted to find out whether bananas fare differently under different storage conditions, our null hypothesis should predict that there will be no correlation between the state of the bananas and the storage conditions. In other words, the bananas should remain exactly the same irrespective of where they are stored. It might be worth mentioning here that the word null stems from the Latin word nullus, which means not, and in French language, the number naught is called nul. Now let's take a look at the alternative hypothesis. Unlike the null hypothesis, the alternative hypothesis expresses the relationship between the two variables. Again, if we go back to our example of bananas, an alternative hypothesis is expected to predict that there is likely to be a difference in the state of the bananas depending on where they are stored, indicating that there is a clear correlation between the two variables, the state of the bananas and the condition of storage, thereby rejecting the null hypothesis. It is also worth mentioning here that the main aim of the alternative hypothesis is either to reject or fail to reject the null hypothesis. Now let us take a look at our four hypotheses. Our research question here is, are widgets from Acme Widget Company defect-free? Based on our definition of null hypothesis, we will have to predict that there is no correlation between the probability of defect, represented on the y-axis, and the number of defective widgets, represented on the x-axis. An alternative hypothesis, however, will predict a correlation between both variables and will therefore reject the null hypothesis. To represent both hypotheses, we simply state for the null hypothesis that the mean is equal to 0, and for the alternative hypothesis, the mean is not equal to 0. On the visualization number 2, we are asked to compare two league teams. The major league team represented by the blue bell curve and the minor league team represented by the red bell curve. Our question here is, does the average major league team have more home run hitters than its corresponding minor league team? Now, unlike the previous slide where we were looking for the mean of one company's product, here we are asked to compare two teams, resulting in the data of both teams plotted on the same graph. In this instance, a null hypothesis should predict no correlation between the level of the league team and the number of home run hitters. while the alternative hypothesis will predict that there is a correlation between the greater league team and the home run hitters. A close examination of both bell curves revealed that the major league team is capable of hitting more home runs than the minor league team. It also demonstrated that the average participant in the major league team is able to contribute one extra home run compared to the participants in the minor league team. This is reflected in the difference found at the central distribution of each bell curve. Based on the above, it is evident that the mean of the major league is not equal to the mean of the minor league. Rather, that the mean of the major league is greater than the mean of the minor league, thereby once again rejecting the null hypothesis. As with the previous slide, this visualization is also capturing a comparison. However, in this slide, we are looking at the mean of a number of teams per group, the efficiency of the blue servers as opposed to the efficiency of the red servers. The testable statement here is pretty straightforward. Do the teams have equal mean efficiencies? Based on the visual representation of the data collated, it is clear that the mean for the red team is not equal to the mean of the blue team. So whereas the null hypothesis would seek to predict that the mean number served per hour for the blue team will be equal to the mean number served per hour of the red team, the alternative hypothesis will be the mean number served per hour for the red team will be greater or less than the number served per hour for the blue team. In this slide, we are asked to establish the correlation between two variables, the weight of the car plotted on the y-axis and the miles per gallon of petrol consumed by the German car plotted on the x-axis. In spite of the fact that the researchers forgot to state their hypothesis, our knowledge of hypotheses indicates that a null hypothesis generally predicts a no correlation between two variables, while an alternative hypothesis generally predicts a correlation between the variables. Furthermore, in this case, we are given a p-value of less than 0.0001, which is far smaller than the standard p-value of 0.05. With a p-value this low, the chances of the results of the test happening by chance is very unlikely. Therefore, we have to conclude that the results from tests performed by the researchers, which found a significant correlation between the weight of the car and the miles per gallon of petrol consumed, is valid, and we must therefore reject the null hypothesis. Now that we have looked at our four hypothesis testing in detail, I would now like to spend the last few moments looking at some important takeaways from the session. The first thing I'd like to stress is a hypothesis must be testable. If a statement is not able to stand up to scientific scrutiny or scientific testing, it is not a hypothesis. The second thing is a null and an alternative hypothesis cannot stand together. The main aim of an alternative hypothesis is either to reject or fail to reject a null hypothesis. Now moving on to using visualization. Visualization makes interpretation of data quicker and easier to read and to interpret. The visual representation speaks for itself and is also very compelling and difficult to refute. If you remember the examples I related to at the beginning of our session about the bananas, this is what happens when you leave bananas out in the sun. As you can see, this is an alternative hypothesis and it's very difficult to argue with a compelling visual representation like this. Finally, I must say I have thoroughly enjoyed putting this presentation together and I have learned a whole lot in the process. I hope you find my presentation as informative and as useful as I have. Of course, if you have any questions, I'll be happy to address them at this time. Thank you very much.